Welcome to our session today. It's that time of the year again when we're facing exams, and I know for many of you, you get nervous, but that's why we're here, to help you to cope with all those exam blues. Today we're going to be looking at data representation, and to start off with, we're going to do a little bit of an overview of the whole section. The first thing, you'll remember that data representation has bar graphs, there are histograms, pie charts, the compound bar graphs, and then we'll also be talking about interpretation, because some of the charts that you will be presented with might not fit the standard sort of bar chart or histogram look, and you'll need to learn how to interpret different charts. There's also the misrepresentation of data, a key feature when it comes to doing interpretation. Let's start off with some tips on bar graphs. Remember that the data is represented in vertical or horizontal bars. So those bars are either facing up or they're running across. The bars are separated, and this is important, indicating discrete data. That term, discrete, means that the data is not linked from one value to the next. In other words, the chart itself has differing values on it, and as we look at some examples later, I will point out to you why the values aren't following on one from the other. Remember that the size or the different categories of data are compared in terms of size. So if we have one category and we have a very short bar, and then next door is a category with a very long bar, it would necessarily mean that the long bar is a greater value category or has a greater value in it. And then lastly, that the bar lengths are proportional to the size of the data and therefore need a scale. So you can't just choose a value and say, well, let's make this one short, that one long. You've got to make sure that if one is longer and it looks like it's about double the other, that it actually represents a value that is double another value. Again, we'll look at this in more detail when we get to some examples. Then there are the histograms, and often the bar charts and the histograms are the ones that are easily confused, especially when one is asked to draw these charts. The histogram is used to represent one category of data that can be broken down into different ranges of values. And this is important to realize. In the bar chart, we had different categories. In the histogram, there is one category, but the values follow on one from the other. There is also no space between the bars, and this indicates that the data is continuous. In other words, that one value does follow on from the last value. Notice again that the bar sizes reflect the frequency of data in each value range. Thirdly, there are the pie charts. Again, I find that many of the students are often confused as to which chart, when they're asked to represent data, they have to use. This one is used to represent data that represents fractions of a whole. For example, the different grades in a school. If you know that a school has 350 students and there are 5 grades, you can ask, well, how many people are in each grade? The number of people in each grade will always be less than the total. That stands to reason. The fraction or the percentage in each grade is what it will be represented in the pie chart. So the whole circle of the pie represents the total number of students in the school, whereas when we divide the pie up into sections, we will see that those fractional parts, each grade 8, 9, 10, 11, and 12, will take up a portion of that circle. It says here that the pie slices represent a percentage of the whole, and the total pie is always equal to 100%. You can never have data that goes over 100% represented in a pie chart, because the whole idea of a pie chart is that it represents portions of a 100% whole. Then the ones that usually get asked in the exams, the compound bar charts. Just like the previous one, they're used to represent one category of data that can be divided perhaps into 2 or 3 parts. Example, if we are doing sales year on year, maybe car sales, and we want to know this year how many Toyotas did we sell. Then we want to compare in the following year. We also want to see how many Toyotas we sold so we can make a comparison between the 2 years. That's a wonderful example to use to represent it using a compound bar chart. The parts can be reflected as one bar split in 2 or perhaps 2 bars next to each other. Let's have a look at what that looks like. I have a picture here. Here you can see the 2 parts are split and the one is on top of the other, or we can see that the 2 parts are again split but the one is represented next to the other. Again, it's key to make the choice in the examinations and make the correct choice. When would you use one where there are 2 bars on top of each other, and when would it be good to use one when the bars are next to each other? Well, in the example that I gave you about the Toyotas, the one where the charts or the bars are next to each other would be great to use for that one because we have 2 separate years. We would put maybe 2010 over here on the white one and then 2011 next door. But if we had data, for example, where we had a number of people who were visiting a certain theme park, perhaps something like Gold Reef City, and we wanted to compare the number of women compared to the number of men that attended that theme park, that would be a wonderful compound bar chart where we could place the 2 on top of each other. We could make the blue, for example, the women, and the white, the men. And then we could also then see the total number of people very easily. That's why it would be easier to see if we put the 2 data inputs on top of each other rather than next door. It just gives us an added feature of seeing the total as well. That's not to say that we're not interested in the total of the 2 years for the Toyotas. We could have been, but usually it is easier when we're talking about cars and year-on-year sales to put them next to each other. Then we have the misrepresentation of data. Remember that sometimes in a chart there is a purposeful misrepresentation to make you believe something from that chart that maybe isn't entirely true. This often happens in statistics when people want to try and convince you of something, and they draw a chart to show you, well, this is what the data looks like for maybe a period of years. The problem often is, like I say, that they're trying to actually misrepresent that data, and you need to be careful and check why they are doing that. So we're going to look at some examples that purposefully misrepresent the data in a little while. Look out for things when you're looking at charts, such as inconsistent scales. Also, check where your scale starts. Scales don't always start at 0, and they should if you want to have an accurate chart. And scales that are exaggerated by using small increments. For example, if you see a chart that's jumping up and down and making lots of changes, you might think, well, there's been a big change from one year to the next or whatever they're trying to represent. But if you look on the side at the scale, you'll see that actually the amounts that they've listed from on the left-hand side of the scale are actually very small changes. And so the scale itself has caused an exaggerated effect. Quickly before we finish off, we're going to look at some common errors that occur when we're answering these types of questions. The first one, not labeling charts. Secondly, not using an accurate scale or equal divisions. Remember, if you've got data and your range goes, for example, from maybe 0 up to 1,000, you don't want to go up in amounts of 10 on the left-hand side of your scale or on the y-axis, because you'd have to put in 100 spots, 0, 10, 20, 30, all the way up to 1,000. It would be far easier to use a scale where each block that you have given represents 100 units. Then you only need 10 blocks. Then, using an incorrect chart to represent data. Remember, if you've got data, for example, where you've got a whole and there are fractions of that whole, it would not be great to use a bar chart in this case. A pie chart would be the right chart to use. So decide up front and think carefully which chart is going to be the most suitable when representing the data that's given to you. And then lastly, assuming a scale starts at 0 when calculating the value of data on the chart, make sure that you do understand that if you have data that doesn't start at 0, that you have a 0 point in your scale anyway. Otherwise, again, you're going to have data that looks inaccurate on the chart if you don't get your scale right down to 0. Remember, it should start at 0, and even if there's a big gap between 0 and the next number, reflect that accurately in your data using a good scale. Some quick hints. Ensure equal spacing on your scale by considering the highest and the lowest values of the data. If you're unsure as to how to get your scale correct on your left-hand side or your y-axis, look at the total in terms of the highest value and the lowest value. Take that and then say, well, how many blocks do I want? If your highest value, for example, again is 1,000 and your lowest value is, say, 600, well, that leaves you with 400 between your highest and your lowest. 1,000 minus 600 is 400. If you want maybe 8 blocks, then you would have to divide each block into units of 50. However, this one is a good example where I have left out the 0 scaling, because if we're starting and the highest value is 1,000, but we're considering that our lowest value is 600, we've ignored the fact that actually there's a big gap between the 600 and the 0. So the safest bet for your data, so that you do not get an exaggerated effect, is actually to say, I'm going from 1,000 to 0. Let's make blocks of 100, and then we can fit 10 blocks in. Even when we're representing the data, we will start our first data point at 600, and so it'll be quite high up on the chart, but we will have an accurate reflection on the data chart. So usually the best thing to do is look at the highest value and actually go down all the way to 0, even if your lowest value is not a 0. Use a whole page if asked to draw a chart. Often in the examinations, we'll see these little small graphs or charts bunched up into a corner near the bottom of the page. And really, that's not helpful when it comes to marking. Because the examiner struggles, you must remember, examiners are older and their eyesight's not as good as it used to be. And they don't have the time to just look for all the little bits of data if they can't see it accurately. And that's going to lead to a situation where you will end up losing marks. So rather, take a fresh page and make a nice big chart. Use the whole page for the chart. That will give you a much better drawing, as well as making your data more accurate to read off at a later stage. And use a ruler or a compass when drawing charts. If it's a pie chart and you need to draw a good circle, use a compass. Make sure you bring one to the examinations. Use a ruler to draw your bars so that the bars are nice and straight, so that they look good. That will make it easier for marking, and of course that will benefit you because you'll be getting better marks in the long run. Do not draw freehand charts in the exam. Lastly, again, just to remind you, give the chart a heading and label your axes. All the best.